Solving a compound linear inequality, and we're going to graph the solutions so we don't have to put them as an inequality again. With these, that just means we have two parts, so two inequalities. They could be together, they could be separated with an and or an or, but we're going to do each part by itself. So to start with, we have 2x plus 4 is greater than or equal to 10, and then the other one that we're going to solve is 4x minus 4 is less than or equal to 20. Now, the one thing that you do have to remember whenever we're doing inequalities is if you multiply or divide both sides by a negative number, meaning you're bringing a negative number over from one side to the other with either multiplying or dividing, you do have to flip the inequality with it. So this problem, it's not going to happen because occur because our coefficients are all positive, but I just wanted to remind us that we have that. So we're going to solve inequalities just like we do equations. Don't change the symbol to an equal sign because that just can mess things up because we have to remember where it's going to go and how it's going to face. So I'm going to subtract 4 from both sides on this one. And I have 2x is greater than or equal to 6. Then I divide both sides by 2. And 2 is a positive, so that's good. So x is greater than or equal to 3. So at 3, I am going to put a closed circle because it's an or equal to. So closed circle. And x is got the bigger part of the inequality. So I need x to be bigger than 3, which means it's going this way. I'm just going to put a small arrow to start with. Solving the other equation, or inequality, is I'm going to add 4 to both sides. Alright, so I have 4x is less than or equal to 24. Divide both sides by 4. And I have x is less than 6. So at 6, I'm going to put a closed circle. And the pointy part of the inequality is by the x, so I need x to be smaller than 6. Meaning it is going this way. My arrows are going to meet, so my answer is between those two, and I would be shading those in my problem. All right, so then we're going to do another one just to make sure that we have this right. If I was writing the inequality, I can keep them in order, and it would be 3 is the first thing I see, and it's got a less than or equal to, because I like less than or equal to's. The shaded part is in between, so I put the x, and then I have the 6 also has a closed-in circle, so it's less than or equal to. So that would be the answer if I had to write it down in set builder notation. All right, so we're going to do one more, which is 3x minus 2 is greater than 1, or 2x minus 5 is less than negative 9. All right, solving the first one, I'm going to add 2. I have 3x is greater than 3. Divide by 3. I have x is greater than 1. So at 1, I'm going to have an open circle. And x has got the open part. It is going to be bigger. It's going this way. Solve the other equation. I'm going to add 5. And I've got 2x is less than negative 4. I'm going to divide both sides by 2. Even though my answer is going to be negative, I don't get to flip the inequality because it's what I'm dividing by. I'm dividing by a positive, so I'm perfectly fine keeping the inequality the way that I want, and I want to keep it that way. So that's negative 2. So x is smaller than negative 2. So at negative 2, I have an open circle as well. And I need the numbers smaller than that because the x has got the smaller part of the inequality. So my graph looks like this. There's an open gap with it, so I'm shading this way, and I'm shading this way. If I had to write it, it would be in interval notation. It is going from negative infinity, and it is going all the way up until I get to negative 2, which is an open circle. There is a gap, so there's a U, and then it's an open circle at 1, and it's going to infinity. Infinities always get the rounded things. If I was writing it as an inequality, I would say at -2. There's shading before this, so this is x is less than -2, or, because there's a gap, x is greater than 1. So if we end up with an or, we do want the x's first. We like to use less than more than greater thans, but we like the x's first, or we like it to be in order.